Kind of a long passage here, but let's take a look. It's a little sciencey. Let's see. Scientists studying Mars long thought the history of its crust was relatively simple. So long thought already, they were wrong, is what I get out of that. One reason for this is that geologic and climate data collected by a spacecraft showed that the crust was largely composed of basalt, likely as a result of intense volcanic activity that brought about a magma ocean, which then cooled to form the planet's surface. Whew, not going to try to absorb that. We'll come back to it if we need it. A study led by Valerie Pear focused on additional information, further analysis of data collected by the spacecraft and infrared wavelengths detected from Mars' surface. So additional information. That revealed the presence of surprisingly high concentrations of silica in certain regions on Mars. Since a planetary surface that formed in a mostly basaltic environment would be unlikely to contain large amount of silica, Pear concluded that, original theory wrong, something like that. Right? So they thought something, they long thought something. This person comes around with some additional information. They said before it's something to do with the basalt. Then there's nothing about silica, and the basalt would be unlikely to contain large amount of silica. So the basalt and the silica don't mix is basically what I'm getting, right? Like I don't really understand it, but I get that there's a problem with the original theory. So let's stick with that. So we want something that says that something like the original theory was wrong. Let's take a look. A, the information about silica concentrations collected by the spacecraft is likely more reliable than the silica information gleaned from infrared wavelengths detected from Mars' surface. So obviously this is a comparison, right? More reliable comparison, one of our most common trap answers. And what are they comparing? They're comparing both pieces of evidence that this new person used. If we want to make a comparison here, we want to compare the old information to the new information. This is just the two types of new information that they got, so this is not focused on the right stuff. B, high silica concentrations on Mars likely formed from a different process than that which formed the crust of other planets. Maybe, but other planets? Are we really talking about that? I don't really know. Maybe they kind of talk about that at the end, but I don't love that they're bringing that in. That seems kind of random. It seems like we're focused on Mars, so let's stick with that. And let's trust our dumb summary here. I was pretty sure that we're looking for something that says the original theory is wrong. This doesn't seem to be saying that. This is saying something else. So I'll keep it, but let's look at C. Having a clearer understanding of the composition of Mars's crust and the processes by which it formed will provide more insight into how Earth's crust formed. Yeah, I don't care. Who cares about Earth? Don't care. D. Mars's crust likely formed as a result of other major geological events in addition to the cooling of a magma ocean. Okay, right? So already that vaguely sounds like there's something else going on, which is a complicated version of the original theory was wrong. And what was the original theory, right? Was the original theory the cooling of a magma ocean? I do kind of remember that. Let's go back, right? Magma ocean, intense volcanic activity, and cooled to form the planet's surface. Okay. And they're saying the spacecraft showed that the crust was largely composed of basalt, which comes from the cooling of the magma ocean. So the stuff that I ignored earlier, because I was like, it probably either won't matter or I'll worry about it later. I'd have to worry about it later, but now I understand it much better because I have like a task. I'm like, okay, understand it in the context of it being the way that it cooled, the way the basalt formed, and then there's other major geological events because this other person found this silica thing that says the other theory is wrong. So it's not, D is not going quite as far to say it's totally wrong, but it is saying that it's not complete. So maybe it's got to be softer, but I think for the purposes of understanding the choices, our dumb summary was good. It helped me focus on the right things. It helped me not get all caught up in the science that didn't matter and some of these other choices. And then when I did need to interpret something, I had a clear idea that I could use to kind of read the science with and be like, okay, I don't care really about what's happening. I just need to know, is this the theory that they now say is not a great theory, is not a complete theory? And yeah, I can look back at the science with a clearer idea of what I want. So to me, I'm very confident in D. No need to go back to B. I didn't think it was good anyway, and I like D better, so we'd be done. This is definitely a question where I would have been very confident in my answer because I had a very clear sense of what I wanted when I left the passage in the blank there.